A chemical bond is a lasting attraction between atoms, ions, or molecules that enables the formation of chemical compounds. The bond may result from the electrostatic force of attraction between oppositely charged ions, as in ionic bonds, or through the sharing of electrons, as in covalent bonds. Ionic bonding is the complete transfer of valence electrons between atoms. It is a type of chemical bond that generates two oppositely charged ions. In ionic bonds, the metal loses electrons to become a positively charged cation, whereas the non-metal accepts those electrons to become a negatively charged anion. Properties of ionic compounds. Ionic compounds form crystals. They have higher enthalpies of fusion and vaporization than molecular compounds. They are hard and they are brittle. They have high melting points and also high boiling points. And they conduct electricity, but only when they are dissolved in water. Examples of ionic bonds are the chemical compounds sodium chloride and lithium fluoride. A covalent bond, also called a molecular bond, is a chemical bond that involves the sharing of electron pairs between atoms. These electron pairs are known as shared pairs or bonding pairs, and the stable balance of attractive and repulsive forces between atoms when they share electrons is known as covalent bonding. Covalent bond properties. Covalent compounds have low melting and boiling points. Many covalent compounds are gases at room temperature, for example, carbon. However, paraffin wax is a solid at room temperature. Covalent compounds tend to be soft and flexible, unlike ionic compounds, and they don't conduct electricity. Examples of covalent bonds are water, diamonds, and carbon monoxide. Lewis structures, also called electron dot structures or electron dot diagrams, are diagrams that show the bonding between atoms of a molecule and the lone pairs of electrons that may exist in the molecule. First, identify the central atom. If a molecule consists of 3 or more atoms, the element written first in the formula, unless it's hydrogen, is the central atom of the molecule. Hydrogen is never the central atom. If the first element in the formula is hydrogen, then the next element in the formula is the central atom. Next, draw the terminal atoms. Draw the remaining atoms by writing their chemical symbols around the central atom. In this case, write the chemical symbols H and N on either side of the central carbon atom. Now add the valence electrons of all the atoms. Next, draw single bonds between the atoms. Remember, each bond consists of 2 electrons. Now, beginning with the outer atoms, represent the remaining valence electrons as dots. Do the central atom last. Also, don't exceed the total number of 8 valence electrons, 2 for hydrogen. If there aren't enough electrons available to give each atom 8 valence electrons, then bring one of the electron pairs to make an additional bond with the central atom. Repeat this step as needed until the central atom has 8 valence electrons. Each atom should have 8 valence electrons, and the total number of valence electrons in the molecule should equal the number determined at the beginning. Now, moving on to metallic bonding, which is a type of chemical bonding that rises from the electrostatic attractive force between conduction electrons in the form of an electron cloud of delocalized electrons and positively charged metal ions. Metallic bonding accounts for many physical properties of metals, such as strength, thermal and electrical resistivity and conductivity, opacity, and luster. Some examples of metallic bonds are iron, cobalt, calcium, and magnesium.